Hey everybody, thanks for coming to our talk. We're going to talk a little bit about GraphQL today, especially how you can make it go really fast, or accelerated as we like to call it. I'm Matthias, I go by Macintosh on GitHub and NPM.
I'm Matteo, hi.
We both do a lot of open source, in fact probably so much that either of you had probably used some of our stuff at some point, I'm guessing.
Yeah, definitely. Look, if you grab that node modules folder, there's definitely some stuff.
Yes, you're welcome.
We both work for Nearform. We are a JavaScript consultancy company based in Ireland, but we really work throughout the globe. I don't know, Matthias, you came from Buenos Aires, right?
Buenos Aires, yeah.
Yeah, okay. I came from Italy, so whatever. We help companies develop, deploy, scale, build, design, whatever, JavaScript applications. So we are really big into helping spreading the word of JavaScript and Node.js and React and all the new world of software development, really. So let's start talking a little bit about web applications and the REST pattern. So that's the REST architecture. So let's say that if you want to get your friends on Facebook, very common thing, right? So you know what you will get. It's more or less something like this. You have a big array in your JSON data, and for each person of each of your friends, you have a huge amount of properties. Hey, a lot of properties, and this thing can be actually big. But my application, I'm building something on the front end, and my application is only interested in the name. So what do? Do we add another custom endpoint, which is Facebook friends' names? Or maybe we add a filter query parameter to actually get only the name? The problem with both of those approaches is non-standard, really. So yeah, I don't know, like a lot of REST endpoints, right?
So also, what about this problem of, maybe in most applications, we're not just interested about one thing. If I'm getting my Facebook friends, I probably also want to get a bunch of, what they're liking. That's like, how you know if they're actually friends. So how do you do this? Do we just make multiple requests? Or if you do multiple requests, that's like multiple round trips maybe, or it's like actually multiple connections. So, it comes at the overhead. If we try to optimize this, we can try to merge these together into like a joint endpoint, but that kind of gives us the same problem. We're going to run out of URLs really fast, right? This doesn't scale that well.
So I was working at some point on an application for a newspaper, and I was involved in some of the decisions there. And at the beginning, there was an API for the web app. Fantastic. But then the Android team started working, and it came apparent very quickly that they need some specific endpoints for the need of the Android app. Guess what's the next step? Then the iOS team started, and they needed some different API endpoints, again, for the specific needs of the iOS app. Like maintaining all of those endpoints comes at a cost, okay? It's software that needs to be maintained, deployed, and so on and so forth. So maybe there is another way, a new way.
Yeah, so basically you're probably all familiar with this if you've ever heard about GraphQL. But GraphQL is a language that tries to solve some of these things. And it tries to solve all of this in very developer-friendly ways that are very approachable. And it kind of looks like this, where you write these queries in this very concise syntax. This is a friends query, where you say, I'm looking for friends. The input is a name, and the name is Matthias because that's my name. And then the really cool thing is that you have to specify straight away basically what you're interested in. I'm only interested in the name, so you just write the name, but you would add the properties there that you're interested in. So very concise, very small way, and it kind of forces you to pick only the things you're interested in, reducing the payloads you send back, making it very small and efficient. Basically, creating a better user experience because things will load faster and a better developer experience also. It also comes, with classic modern features such as type validation. So on the server, you have to define what types do you accept and return. Here, we have a friend. You have to say it has a name. It's a string. Could be another complex type. Similarly, if you've ever done stuff with JSON schema, which I'm sure most people are familiar with, it also, you also have to define the queries you support, the input, the output, the names.
You can get pretty advanced with this. Okay, you can every property on your types can actually be resolved by a query and so on and so forth. So it can get even pretty advanced and pretty complicated as well.
And it's just a language, so it's just a way to express these things. You of course still have on your server to provide the implementation for the queries. It's not a magic thing like that just makes your friends appear. That'd be cool though. So it's just, it's a language to help express these relationships. So it's really interesting. I'm sure lots of people in here have tried it before.
So one of the key things about GraphQL is that it enables you to ask for to do multiple queries at the same time over a single round trip, a single request response round trip to the server, reducing the number of calls that you're doing and overall providing a better user experience. So in this query, we are actually asking for both the friends of Matthias and my friends. Hey, and we can even get different properties on all the different queries. On top of this, there is these features that I love, which is GraphQL also supports something like prepare a statement in SQL. I'm talking about SQL, but I've done a lot of that, like queries this big. So you can actually write some kind of prepare a statement or queries that are parametric and they support variables. So basically the query more or less stays constant, so you don't have to concatenate strings, so you don't have injections, so you have all of your code is a little bit more secure. So hey, we like this. So yes.
It's a nice concise language to work with. It has all the modern features we would expect from anything being released in recent years. And one of the really interesting things also is that it has a really, really rich ecosystem because it's got pretty wide developer adoption. So there's really cool things out there like graphical query editors to help debug, see the flow, all kinds of tooling. You basically don't have to write any tooling yourself. It's truly phenomenal. And one of the very popular things out there is something called Apollo. So Apollo is kind of like a batteries included, fully featured client-server framework that helps you write GraphQL applications. And it basically, the gist of it is like it lets you come up and running with a GraphQL server endpoint and client in like 10, 20 lines of code for the initial setup, which is very nice when you're just like prototyping and want to get up and running really fast and just try it out or prototype some new ideas. So really interesting stuff.
Yes, but it comes at a cost. GraphQL is a very powerful abstraction, and as in any application that you are building, the more layers you introduce between your data and the actual users, the more this creates this more introduced over it. Okay, because the more layers it does, this data needs to flow through more steps, more CPU cycles are burned. And so on. So every layer that you are introducing comes at a cost. Bear in mind, also logging comes at a cost. So nothing is free, more or less. Okay. So what we have seen in the last few months, that several of our clients reached out to us and they were asking us, but we have some performance issues with our GraphQL queries and the GraphQL servers. And it was like, we were pretty new to this world, and we started investigating and doing some research on how to improve the performance of GraphQL endpoints. And we use our suite of tools called Node Clinic, which we also will present. Matthias and David will present this afternoon during a workshop, so you are welcome, of course. And this suite of tools is a suite for helping diagnosing and debugging performance issues in your Node.js application. So what we have done, we use one of the tools, including in Clinic, to generate a flame graph. So you create Clinic flame, and these will wrap your node process and get some metadata to generate what is a flame graph. I show this in a second. And then you run a little bit of a benchmark and you apply some load to it. And
so basically, the thing we wanted to test is just like, what is the overhead of GraphQL? by itself, not the operations you run behind it, but just like, we want to write REST endpoints. What's the cost of GraphQL?
Yes, so basically this is just sum two numbers, okay? Like what is the cost of summing two numbers via GraphQL?
Like a minimal test case,
Yes, very minimal. So this is the type of visualizations that Clinic Flame generates, which is called a flame graph. And you can see a lot of documentation about flame graphs offline. We've done several talks about it in the past, so you can, if you want to come by, I will give you some pointers. But the key important part, and you can see that in that little red box over there, it's that the more color, the more red it is, the more hot that method is, which means that takes more time on the CPU and gets executing more and more and more. And we can see that I don't know if you can read this, but it's called enter, and the other one next to it that is pretty hot is called leave. And all of this, if we walk down the stack, we see that a visit method is in there, and it comes from validate. And we can guess that we are somewhat validating something using a visitor pattern. I'm sorry if I'm mentioning a visitor pattern, but if it's one of those computer science thingy. But why is this happening, Matthias?
So basically, what the flame graph allows us to do is, we look at it and you clearly saw there's something going on that's very hot. And people might think, oh, that's too bad. But we're performance optimizers. So when we see something like that, we get excited because that means we have something to do. If there was nothing there, we would just have a 10-minute talk and then
done. Yeah, bye.
So always exciting. So basically, we use this as a signal to go through the various code bases, and we basically just started reading one into another through the GraphQL code base, which is really solid in general, and basically found out that on every request your server has, when you send a GraphQL query to it, the first thing the server has to do is parse that query. Parsing a query is it's the same kind of technique for like when you're compiling code. Basically, you're taking some representation and you're producing another one. The thing you're producing is something very fancy called an abstract syntax tree. Similar to if you're transpiling code with Babel, actually, that's the same kind of thing. So this huge tree that's represented in JavaScript that basically represents the query, but in a different format. Then you have to take that syntax tree. You have to validate it, first of all, that it's a valid GraphQL one. Maybe somebody is just typing hello world to your server and seeing what happens. I'm sure a lot of people think that's pretty funny. And validate it, and you also have to run through and validate your input. You have to apply all that type validation we talked about, et cetera, et cetera. And only then can you go through the visitor pattern, visit every node in the syntax tree, and then execute your query. So it's basically a lot of work you have to do on every request, right? So this is on every request you get in. So imagine running Babel every time somebody requested your server. It's not
you can try.
You can try. So how can we approach this and make this faster? Well, to us, we kind of like this kind of problem because it had a simple solution.
Very simple.
As a simple solution. Just throw some caching at it. Caching is one of those things that just makes everything faster in computing in general. It's also very tricky.
It's also one of the hardest things in computer science.
It's like one of the best thing and the hardest things.
Be careful.
So basically, so we have that. We have GraphQL queries. GraphQL queries are just strings, right? At the end of the day, they're just strings. We have an application. We control the backend usually because we're writing the application. We
write enterprise software, okay? We help companies write enterprise software. So, in those cases, we control both the server and the client and so on. It's not for building.
So, we can kind of control which queries we're sending. And we're not sending that many. We're probably sending 100, something like that. Yeah. Very, very few queries. And the queries don't have any variables in there, like Matteo said, for security reasons, we send them on the side. So actually, the queries are really static at the end of the day, right? It's just static strings. So instead of repassing those static strings over and over again, we can just apply some caching to it. And
so we started working on experimental implementation of this caching idea, which is fundamentally we wanted to prove that does this work? Okay, can we use this caching concept for accelerating GraphQL? Can this be used in the context of enterprise applications and so on? And of course, we are not just caching forever. We are using a least recently used pattern to avoid filling up the memory with all those ASTs, which are actually pretty big stuff. So we don't really want to fill the memory. So we keep them around for some time. And so we can cache the stable queries for a significant amount for some time. So we did this experimentation, and we wrote this fastify-GQL module that you can install and try out. It's, as I said, experimental. So be careful. Report bugs. There's no docs, more or less. Not much time for docs at this point, so we'll add docs, no worries. But all of the techniques that we have done could be applied to all the other GraphQL implementation, and we'll reach out sooner rather than later to get them to adopt similar techniques. So this is, they didn't refresh this. That was a slide that shouldn't have been there. So this is how you use it. It's very simple, again, very easy, and similar concept of the other ones. Again, you have your query, you have your resolvers, and things like that. So this is the result of this technique. And you can see that we get a significant performance improvement on using this new caching pattern. So by using this caching pattern, we are able to, give us 3 to 4 times more throughput to our GraphQL solution. But when doing this, it will be. We still have like 4 more minutes in our talk. So what we will talk about?
So being thorough engineers, and we're pretty thorough, I like to think. Right?
Okay, yeah. We're humble and modest.
We weren't done yet because we're not done performance tuning until there's nothing left to do. So what we decided to do was let's do another performance analysis on this caching layer. Maybe something is there we don't know about. So we basically just added the improvements Matteo talked about, and then ran our benchmarks again and did another flame graph. And we're actually very surprised to see the results come back. So this is the flame graph of the caching technique. As you can see, there's still a very, very hot pattern in this code. There's something super red. That's what I love about flame graphs. It's just like, look at the red part.
Boom.
There it is.
There it is.
And so basically, it's really hard to see from, the font is pretty small from here, but basically the problem there is that we might be caching the AST, and that's not in the flame graph anymore, but we're still walking it. We still, we have a cache, we still need to go through that tree. And that's still surprisingly expensive. The visitor pattern is not free if you're writing very high performance servers. So we were like, how can we fix this? How can we make this better? So we decided to throw some mad science at it. Basically, throw some on-the-fly code generation at the problem. So if you're not familiar with that, that's a technique where you basically auto-generate JavaScript based on some input instead of writing it.
By the way, it's pretty unsafe.
Super
okay?
unsafe. You gotta be very careful.
Be very careful. Don't try this at home. If you try this at home, we are not responsible for it. Okay? There are some libraries that we have developed to make this a little bit more safer. In this specific case, again, the ASTs and the queries and everything has already been parsed, so it's validated and stuff. So we feel we can apply this approach here, okay? But be careful.
Be careful.
Be careful. Dragons are laying around in here.
So we've basically implemented a pipeline that looks kind of like this, where you have our server, any GraphQL endpoint. There's queries coming in. Then we do 2 things first. One, we detect if the query is hot or cold. Basically, is this being used a lot or is this not being used a lot? If it's cold, we just apply our caching techniques. They're still really, really good, really fast, and kind of like no-brainer. But if they're hot, we do something interesting. We take the query and we on-the-fly compile it to JavaScript. So this JavaScript we compile is basically similar to what you would write if you're just writing the validation in queries by hand. So pretty straightforward JavaScript.
If you're thinking about doing similar approach to solve an analogous problem, be careful that generating this JavaScript function is actually a very expensive operation.
Yeah, so it's the same as a compile step. It's
a compile step, really. So you basically.
But it's really easy in JavaScript because we have these, magic eval functions that we were always taught not to use, but then in practice they're really cool because.
You can always disable ESLint, right?
Yeah, just add some comments. It's all good. So we produced this JavaScript. And then, V8 sees this JavaScript and it's like, oh, this JavaScript is being called all over again. So that kicks in, and it's like, oh, I'm just going to compile this to machine code or whatever magic they're doing.
It's phenomenal. Turbofan and so on. There is a nice lot of story there. Lots of performance improvements in Node Core.
Basically making everything really fast. So, we ran the benchmarks. Oh, yeah, sorry. And this code kind of looks like this. So it's just like a bunch of async functions.
This is purposefully unreadable on the screen. Okay?
It's just computers writing. We should call this artificial intelligence. Maybe.
Yeah, okay.
Computers writing code, basically. Right?
That's what it is, right?
That's what it is. So the results were actually really good. We ended up just by applying this technique, squeezing out on our hello world stuff 30% more performance, and the results are actually really promising also when we added more complex queries like you would see in practice. We don't have statistically significant numbers yet, but they were more closer to a 2x improvement. So, really, really fast stuff. Super exciting.
Note that with the accelerators, the current bottleneck is actually parsing the query string or the JavaScript payload. Or the JSON payload, so that's become the bottleneck. So whatever. That's
HTTP stuff.
Yeah, HTTP stuff, yes.
Yeah. So that was super exciting stuff.
So the full reason for this talk is to show that GraphQL can actually be extremely competitive against a REST and against a REST application, okay? Especially because of the huge advantage in the developer tooling and all the phenomenal ecosystem it's there. Whoa, that doc is amazing. But with GraphQL, with the research that we've done and the improvement that we have made, I think we can actually make it really performance compatible with more traditional REST-based application. So basically bridging that gap and solving some of the problems that some of our clients were indeed having at the beginning. If you are more...
So I also just want to mention that our JIT compiler is actually, it's going to be open source. We're still working on it. And again, this is like, we want to make sure that it's not going to, have security errors and stuff like that. But it's probably going to be released sometime this year, I think, right?
Yeah, it's the really key thing there. We're not even supporting the full TypeScript, GraphQL language specification. So there are things that are missing, like fragments and stuff.
We're getting there.
We will get there. It's just a matter of finishing up the work. And if you are interested in this topic or in making your Node.js application, JavaScript application faster, more performant, or if you just need help with your architecture and you don't know how to get started with a big application, you can come and talk to us at our booth. We are on over there, Come by, come talk to us. We have also some nice T-shirts. We are a little bit blue, near from blue. And you can also check us out at nearfrom.com.
And we have a workshop later today about basically profiling async activity. All your async code, see where your time is spent. It's happening in the West meeting room. It's one of these rooms, I think, actually.
Yes, they're over there. Over there as well.
At 4:40 p.m. So, stop by if you want to learn stuff about that. That's also super exciting stuff.
It's very exciting stuff, like very flashy visualization. So, yeah, please come by. And
I think that's it. Thank you.
Thank you.
Much.
And if you have any questions, we will be at the booth and we'll be around here for a bit. So.